Okay, we're going to do a couple more examples of taking the derivative. These are kind of special cases. The first one is factoring out the least exponent. And this one actually does a couple of the skills. We're going to have to use the product rule, the chain rule, and then when we simplify, we're going to need to factor out the least exponent. So first of all, you want to start by rewriting the function, if it's got a radical, as an exponent. So we're going to change that square root to the 1/2. So do that whenever you have like a square root or a cubed root or anything like that. Try to turn it into an exponential function. So now we're going to have to use the product rule because we've got x times x squared minus 1 to the 1/2. So we'll have to do, just like we talked about earlier about the product rule, you're going to have to do the first times the derivative of the second, and I'm going to put a bracket around it just to show that it's the derivative of the second. We're going to take care of the power first, which would be 1/2 x squared minus 1 to the negative 1/2. And then we've got to take the derivative of what it's being raised to, or what's inside the parentheses, which would just be 2x. So that's the derivative of the second. And then we'll have plus the second times the derivative of the first, and the derivative of x would just be 1. So that's our derivative. We used the product rule and the chain rule. Let's clean it up a little bit. Notice that I've got a 1/2 here and a 2. Those will cancel out. And then I can combine my x and my x. So the 1/2 will cancel with the 2, and I'll have x squared times x squared minus 1 to the negative 1/2 plus just x squared minus 1 to the 1/2. Now notice here I've got a negative exponent. You never want to leave those in your answer, but I've also got the same binomial raised to 2 different powers. So when you notice that, that's when you're going to factor out the least exponent. So my smallest exponent is the negative 1/2, so that is what I'm going to pull out or divide out. So I'm factoring that out of the whole thing, which is just going to leave me with, think about what factoring out means. It's you're dividing by. So when I divide this by itself, that's just going to leave me with 1. So I'll have x squared times 1 plus, and then here, when I divide this by x squared minus 1 to the negative 1/2, it kind of seems nasty, but it's actually nice things will happen. I'm going to work it out over here on the side. This is what you're doing when you're factoring out. You're dividing out. And remember, what you do with exponents is you subtract them. So this is x squared minus 1 to the 1/2 minus a negative 1/2, which makes that 1/2 plus 1/2, or just 1. So this, when I factor out this from this, it's just going to leave me with x squared minus 1 to the first power. Now you don't have to write that down. It's understood, but I just wanted you to understand where that 1/2 went to. Now, since the x squared minus 1 to the negative 1/2 is outside the parentheses and applied to the whole equation, you can move it to the bottom. And we can go ahead and change that back to a square root. And that leaves you with just x squared plus x squared minus 1 on top, or 2x squared minus 1 over the square root of x squared minus 1. So that's what it's meant when it says factor out the least exponent. A lot of times you won't even be told to do that, but you will know to do it if you have a negative exponent that you need to take care of. The next example is implicit differentiation, and here we're going to find dy dx. So here we've got two variables and it's an equation that equals 0. And we're going to take the derivative with respect to x. Now, anytime you take the derivative of an x, because we're doing it with respect to x, you just do it normally. But any other variable gets a d, in this case, since it's y, gets a dy dx. If you had t's in here or r's in here, you get a dt dx, or with whatever it's with respect to. So here, taking the derivative, the x, just take the derivative normally, so that's 2x, plus I've got 9y squared. I'm going to take care of the power, 18y, but then it gets multiplied by its own dy dx because it is with respect to x. And then minus 4x would just be 4, plus 3y would be 3, but then it gets a dy dx minus 0 equals 0. And you can also, instead of writing dy dx, you can do y prime if you want to, but a lot of times that looks like y to the first power, so just be careful about that. So remember, dy dx is also, we could do y prime. So now what we want to do, since we're trying to find dy dx, is we're going to get every term that has a dy dx on one side and everything else to the other side. So I've got an 18y dy dx plus a 3 dy dx. And then I'm going to move everything else to the other side. So I'll have a negative 2x plus 4 when you move it to the other side. Now you can factor out the dy dx. So I've got 18y plus 3 equals negative 2x plus 4. And I'm going to get dy dx by itself. So dy dx equals negative 2x plus 4 over 18y plus 3. Okay, one last example is finding the equation of the tangent line. Now, anytime you need the equation of the line, you need the slope and one point. So if I give you an equation, remember the derivative is finding the slope. So I need to take the derivative of the original equation, which is 4x plus 3, and I want the slope at this specific point. So I'm going to plug 2 in where I have my x. So that's going to be 4 times 2 plus 3, which gives me a slope of 11 at 210. Now to find the equation of the line, we can do a couple methods. I usually fall back on the point slope form, which is y minus y1 equals m times x minus x1. You can also do slope intercept form and find b. Either way is fine, you'll get the same answer. So I'm just going to do the point slope form. So I've got y minus 10 equals 11 times x minus 2, plugging in the slope and the point. And then we're going to simplify and get it in y equals. Add 10 to both sides. And we end up with y equals 11x minus 12. So that's the equation of the tangent line at the point 210.